Test, 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 test.
Okay.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. How are you today? Fine. And how are you, Sarmina?
Thank you. I'm fine.
Fine.
I'm
Okay.
glad to be here.
Thank you. So today we are here to have a guest lecture from Professor Mina. I would like to introduce her first to you all. Professor Mina Uslu Uysal is a professor from Mechanical Engineering Department of Yildiz Technical University. Is that right?
Yes.
Okay, thank you. Nice to have you here, Professor Mina. Welcome to Indonesia.
Thank you. Thank you very much.
Indonesia is hot, right?
Yes, I'm very
She took a long journey from Turkey to Indonesia, about 20 hours, right?
Yes, 20 hours.
So it's kind of great effort to meet you here for Professor Mina. So let's give us our best attention for her guest lecture. Okay? Are you agree with me? Okay, good. Thank you. So Professor Mina, they are students of Mechanical Engineering Department, and some of them are exchange students from France. Nice to see you. And some of them also postgraduate student here.
Okay.
Yeah, but not much. Most of them are undergraduate student. Okay. Okay. Because we already delayed the lecture time so long, maybe we can start. But first, let me introduce here. We have some colleagues from some laboratories in mechanical department. Here is Mr. Alif, the chief of solid mechanical laboratory, and we have the candidate of professor, Mr. Agus Sigit Pramono. And here we have the Norwegian professor, Mr. Wahyu. And then over there, we have Mr. Yusuf Kailani, Mr. Spigno from Metallurgy Laboratory, and then Mr. Indra Siddhartha, and also Mr. Jilendra Aritaja. Thank you for being here. Okay, now the topic that will be talked with by Professor Mina is about adhesively bonded joint. It's kind of not weird, but we are not familiar with this topic because for undergraduate students, the type of joint that they learn are rivet joint, welded joint, and bolted joint. But we skip the adhesive joint. So that's why this topic is kind of new for us. Even though some of us, the lecturer, also research about this topic.
Yeah, we hope so.
Yeah.
We hope so.
Okay, so please, Professor Mina, please take your time to have a guest lecture.
Okay.
Okay.
Okay. Thank you very much. Are you ready? I want to introduce myself. I'm Uslu Uysal. I'm a member of the mechanic division. I also a crowd of students like us, and my advanced topic is in the mechanical of theoretical, and mechanical of by using of the numerical material. We generally use ANSYS, we generally use abacus. I will introduce to this program, and I will introduce to my specific topic. My master degree from the Poland University of Silesian. and my PhD degree from Yildiz Technical University, my postdoctoral from the US, University of Kentucky. Okay. Firstly, its outline. We introduce and we are teaching of adhesive bonding, and we will learn adhesive types, we will learn applications of the adhesive, and factors of the influencing of the adhesive actions. And then we will learn adhesive failure, and I will show some video for understanding, and we will analysis of the adhesively bonded joint by using of the FEM. FEM, what does it mean FEM? It's finite element method. We generally use it in mechanical engineering, you know that. Firstly, I want to show some video for you. Adhesively bonding, we can describe the joining of the substrates and no-end adherents by means of the adhesive that creates bond between of the surfaces. And adhesive bonding, it results from physical and chemical interaction between of the adhesive and adherent. You can see two adherents, and the adhesive and adherent, it must be intimate connect, and they have a appropriate chemistry for these reactions is occur. Of course, they are used commonly applications. We generally use aerospace structure and transportation, furniture, medicine, and dentistry, and we are interested in constructions. Look at that. Especially we will talk about constructions in the mechanical bonding. What else are structure adhesive? They are used in many aerospace applications. Our aim is robust joining method. So what's the important thing? This joint design is important thing, and bond process also important thing for us. Surface preparations and adhesive selections is important. And for mechanical engineer, we discuss joint design because it's important. We will discuss some strength of the joint, some type of the joint. You can see it's a aerospace part, and they are full advantage of the adhesive joint. They compared mechanical of the past joints. They reduce the stress concentration, and lower assembly cost is the most important thing. And it's a layer, and it's a great fatigue resistance. Fatigue is important factor for us, for mechanics. So they are type of the adhesive material. I generally use epoxy and acrylic material. It's most applications of the aerospace, and generally is available in the form of paste or film. What about of the K factors? Success at buoyant joints. Firstly, adhesive selections and joint design and bonding process and tooling on fixturing also important, and also its quality, of course. What about of the ability of the transverse load? Can you see the design of the adhesive joint is the most critical. You can see it's loaded in the axial load. I mean that this side is sigma x. So it's axial loading. This is good for axial loading because it's a scrap joint. What about that? It's not good loading for the sigma xx because its design is not good. What about of the bonding line? Can you see? The bonding line is good and the bonding line is not good. So stress concentration. If you are loading of the axonal load, I mean of fxx, and you can see a single lap joint, the stress concentrations is near the adhesive length. So it's important to choose bond line thickness. Its excessively thin bond line thickness is unuseful, and also excessively thick bond line thickness is not good for us. You can see some considerations for the selections of the proper adhesive include. We can use shear and peel stress. I mean that in the shear stress is tau, you know that it's tau xy, according to the perpendicular of the axis. What about of the peel stress? If you load it in the single lap joint according to x-axis, I mean that peel stress is sigma yy. Okay, sigma yy. It's a peel stress, and of course, creep is important for all mechanical engineer, and fatigue and elongation and breathlessness is important for adhesively bonded joints. So, of course, important in the fault life and important with the compatibility with the adhesive and adherent, and maybe it's temperature resistance. Yes, we should take a considerations of the temperature resistance and chemical resistance, but it's not my area, chemical resistance. The attentions of the cure time, good temperature time, and good rate. So what about all the other considerations of the drug adhesive selection progress? Adhesive, it's a key point. Adhesive with high elongations, it tends to have less temperature resistance than those they with less elongation due to their toughness agents. You know toughness? Yes, I'm sure. Adhesive with the low elongations, they tend to have higher temperature resistance. So we can film adhesive is tend to have higher elongations. We are developing of the full strength of the bonded joints. It's extremely sensitive the process. Its surface preparation, pre-bond moisture, and its proper adhesive handling by mixturing, and their proper applications of the adherents. It's wetting of the whole surface. Applications of the pressure, it's during cure, and we will ensure of the its exactly good temperature and good time. And preparations of the bond surface is the most important step is removal of the prevents contaminations. In we'll discuss, its name is inclusion. We don't want to inclusion in the adhesive because it's lead to lower of the all bond line strength. So we require of to achieve a robust chemical bonding, and they all generally all adhesively bonding joints is chemically etching and adhesion promoting of the layer and primer or other coating of ultimate strength for bond durability. These are important things for us. So common composites and polymers is surface preparation method. I'm studying of the composites and polymer surface, not metal, and it's some preparation method, grid blasting, sanding, and it's a work environment. It's essential to eliminate of the prevents contamination. Perfect bond surface and adhesive from the any inclusion like a dust and contaminations such as uncured silicones, such as grass, oil. We don't want them. We protect the bond surface. Because inclusion effect is not good for adhesive bonding joints. We define in the finite element analysis, we define inclusion in adhesive, and we will solve their effect in the strength of the bond line. What about the effectiveness of the process is depend of the, of course, human factor, because we are using of the gluting, wear powder nitri, latex gloves, and use high-grade solvents. So after and before the preparations, please avoid the surface contamination. and we use all the adhesive mixing, we will be attention. Okay. I will talk about some adhesive types. It's the main topic. Yeah, you know, an adhesive and glue material is usually liquid or semi-liquid state, and they cured by either evaporations and solvent or by chemical reactions. We mainly divided at the two parts of the adhesive, natural or synthetic. Natural adhesive, it can be from animal, casein from the milk, and bituminone. Natural adhesive, of course, is derived from natural sources, including of the gums, stretch, dextrin, collagen, and low stress applications it's used, like furniture and book binding, etc. They have natural adhesive is strong, while they are incredible of the flexible. Some natural adhesive are waterproof, while the others is soluble in the water. Natural glasses is often slightly more expensive, of course, than the synthetic one. They are not easy to use, and they need to be kept at high temperature. They, in the early techniques of the ball and gloves, it's constructions of the weaponry, we can see in the history. Animal gloves, I have an example from fish glue, animal hoof, and seashell glue. Animal glue are obtained from the skin and internal parts of the animal because of the large quantity. They are conventionally using of the wood joining and madder areas. They are replaced by the synthetic glues. Yeah, it's a different thing. Rabbit skin glue. Rabbit skin glue is another form of the hide glue. It was used of the coat canvas, protect the decay of the canvas fabric from the active components of the linseed oil. And then it's use of some musical instruments. Yeah, it's different rabbit skin glue. And animal hoof glue is derived from the hoof of the animals, especially horses. They made by crushing of the hoof into the small pieces and boiling them in liquid, and then adding of the acid to create of the chemical reactions because it's need the leading of the glue formation. Yeah, casein. It's manufactured from the sort cream, you know, and it's skim milk. Casein-based glue are popular from the woodworking. They use the power it mix cold water and into the smooth, creamy paste like a liquid. Bituminone. You can see bituminone is joint seed. It's asphalt. You know, it's an asphalt solid state and a mineral tar into the semi-fluid state. It may be defined as non-crystalline solid, and viscose material is derived from directly petroleum. What about the synthetic adhesive, thermostatic and thermoplastic? Synthetic adhesive, they are cured by various of the mechanisms. Heating of the chemical reactions and radiations of the curing, such as UV light, and their applications as film, like a coating of the surface. They are a synthetic adhesive. It's first commercially produced of the synthetic adhesive. This label Carsten Kister, and it's elastomer, thermoplastic emissions, and thermoset is basically divided in each them. Thermoplastic adhesive, they are fusible and soluble and poor heat and poor creep. instant, resistant. And they have low and medium shear strength, suffer from the creep at the high loading condition. And they are a good resistance to oil, but it's not good in the water. They are good resistance in the oil, not good in the water. And what about of the polyvinyl acetate? Polyvinyl acetate is some of the thermoplastic advice is include of the polyvinyl. This is low heat tolerances. We can say it's a white glue, maybe you know that, because PVA is known in the white glue for wood, and it's a yellow one is Caterpillar glue. The use of wallpaper adhesive and handcraft bursts like that. Polyvinyl acetate is a huge of the adhesive. What about of the thermosetting adhesive? Thermosetting adhesive, they are transformed into the tough and heat-resistant solids by additions of the catalytic or applications of the heat. So the use on this structure functions bonding metallic parts, especially aircraft, and they are using of the timber constructions, epoxy resin and melamine or phenol, different thing. You can see adhesive being applied of the wieners, more familiar to cabinet and woodworker. Its a traditional name is extramite. They when use high quality but stable fix is required and suitable for laminating in the for houses, for building. You can see pH and MF. It's an engineering adhesive. It's used for how the structure work and quality. pH is important because they use where great strength is required and durable and water resistance. Okay. What about of the MF? It's more expensive and it's used product of the hard decorative plastic laminates and they are professional woodworking. You can see some recircular resin. Glues are these resin are dark viscose liquid. They become a hard a short time. It's not wanting thing. It's a low temperature. They are resistant to heat and it's important. They are resistant to fungi and bacteria. Their water resistance is very good and they used to make exteriorly plywood. I used epoxy resin with its hardener in my all experimental studying. Epoxy is also thermosetting polymer. It's formed from the reactions of the epoxy resin with a polyamine is hardener. It's a good chemical resistance and it's a rigid materials at room temperature. It's a good thing. So in when we are using of the epoxy resin, we glued it the bond line and we generally waiting in the 2 or 3 days because it's secured at the room temperature. It's not necessary heat oven, okay? Not necessary heat oven because for the mechanical engineer, heat is some problem, especially for the calculations of the mechanical properties of the adhesive. You can see, we can define of the material by using of its properties. What is this? It's elastic modulus, yes, and Young modulus and shear modulus. Yeah, we accepting and we try to calculating by theoretically and numerically. But if you use a head is changing every mechanical procedures, and so you know all theoretical applications is harder and harder one. So we don't in the not PhD in the master students we don't use all the heat in the bond adhesively bonded joints. It's used for the type of the material, so like a rubber, plastic, glass, metal, anywhere. Of course, heraldite, it's a important one. This heraldite, it's a good properties. It's a high shear and high peel strength, and it's easy to apply, and it's suitable for bonding and variety of the material, also metal, ceramic, anyway. And I can talk about a silicone sealant. You know that it's a primal design for conventional glazing, and it's easy to apply, and it offers its excellent addition variety of non-porous substrate, like a glass, and like a ceramic tile. It's non-porous. It's a foam fix also. It's excellent spread ability of the faster bonding, and it's using of the in architecture or wood. Marine, yeah, I think I visited your laboratory for the oceans, oceans engineering department. So you are interested in the oceans. It's a good. Also, we have a department of the ocean engineering or management of the shipping department in my university. So it's waterproof and non-soluble. Feasibility is important. So maritime waterproof adhesive, it's good. It's nearly 48 hours continuous water resistance, and it's 1 hour boiling water resistance, and it's super bonding in marine plywood, like a yacht, like that. We have sometimes in the crack in the adherent, so we can use of the crack bond. It's high penetrations. They use of the micro crack treatment, and they use of the polishing or marble then can be done. Spray adhesive also, it's works similarly. What about the applications of the adhesive? It has many areas in our life. Yes, electric industry. Some of them is graphite. Graphite builds electric conductive adhesive, and nickel feed electric conductive adhesive, and silver coated and nickel feed electric conductive adhesive. It's a popular studying area, especially of the graphite field or nanographite field. And I say building, of course, they are using of the wall covering, manufacturing housing, and they are using of the lamination, wall covering. They are interested in for engineering. I will show another video. It's aerospace industry. Look at that. It's an example. Adhesive bonds, laminate, and stringers. That one is the red one. And fiber reinforced plastic, yes. And of course, they're using of the adhesive bonded metal to sandwich, metal to metal, single lob or double lob. So aerospace industry generally use bonding structure, and you can see on the adhesive bond in the laminate that was in green. I want to show, yeah. Maybe I can share the. Oh no. Come on. Okay. Yeah. This film was taken from the Henkel. It's a productor. aerospace engineering, they need for adhesive. They have grown significantly. They also try bonding solution. We can use all the epoxy resin by with the hardener. Can you see in the epoxy resin in this tube, and hardener is another tube, and you can see a mixed head. So it's possible for the glue at the same time. It's a volume ratio 1/2, 1/1. It's provide design flexibility and the aim, of course, reducing all the weight in the aerospace. What about all the distribution stress? The bond line is used for high temperatures. Can you see is a flag? It's a coarse slice adhesive. You can use coarse live adhesive. And then sealant is adgas sealant. Also use them. And the metal to metal, metal stronger to metal stronger adhesive can you use? And coating like a stiffness. Can you see? It's many area. And also, adhesive bonding joint can use in the inside of the aircraft. You can see honey constructions, and you can see a bond line. I mean that it's the alternative method for joining, and they use in many area. Of course, automobile area and textile. Generally, polyester adhesive are recommended for the field of the textile lamination because their bonds they create can withstand washing and cleaning. It will be useful for polyester adhesive. They use other applications in dentistry and some constructions. We are interested in applications of the constructions. Now it's some mechanical behavior, factors of the adhesive action. Is it okay? Do you need a time break? Everything is okay. If you need a time break, it's 10 minutes. I can give you, and then come back to factors of the influencing of the adhesive actions. Do you need? Yeah, okay. I'm okay. If you're okay, I'm okay. Okay. Factors influencing of the adhesive actions. We have some physical factors. The physical factors, they surface tension and porosity and physical characteristic of the film adhesive. What does it mean, surface tension? Look at that. Surface tension is an elastic tendency of the fluid surface. It makes it occur of the least surface are possible. You can see all the water molecules, and you can see all the surface molecules pulled inward. And adhesive. Adhesive is effective only when the interfacial tension between of the adhesive and adherent, it will be minimum level. Okay. Surface tension is important for us. What about of the porosity? Porous materials like paper, wood, leathers, they have large of the capillaries. It's produce more mobile portions of the adhesive. So these disturb the equilibrium between of the solid and solvent in the adhesive. For to get better quality of the bonding, smooth and non-porous the surface is necessary instead of the rough surface. Typical characteristic of the adhesive film. A good adhesive film, it has to be great tensile strength and shear strength and compressive strength. So, negligible of the creep under the distress. The differences between of the thermal coefficients of the film and the thermal coefficients of the adherent, it will be less. Okay? Thermal coefficients of the expansive between of the adhesive and adherents, it should be less for good bond line, for film adhesive and for all adhesive. You can see a thick adhesive film, for example, elastic bandage. A thick adhesive film, it's in parts of the poorer strength, and if the tensile strength and elasticity, the higher for the adhesive film, it produced by the bond strength, it will be more and more and more. And I want to talk about a chemical factor for good adhesive bonding line. Is a polar characteristic of the adhesive, degree of polymerizations, and effect of the pH, and side chains in the adhesive molecules. We take a considerations of the chemical factor, and we have to ensure a good bond design. You can see its adhesive is containing of the polar group. They are strongly absorbed by organic surface. Look at that, is non-polar polymeric adhesive. They are relatively poor in the bonding. Polar molecules will have Casimir Debian force is not experienced by the non-polar molecules of the similar size. Its Casimir interactions and its Debian force, it's not experienced by non-polar molecules. What about the degree of the polymerizations? The number of the nanomeric units in a nanomolecule and a block or like a chain type. The maximum bond of the strength of the adhesive, it must be range of the corresponding to the polymers having a slightly higher than molecular weight than. These polymer molecules, they will have more free valencies attached to the surface, and it will be more effective than the other high molecules. You can see a cellulose, for example. The chemical nature, the length and complexity side of the chain adhesive is determined of the bond strength. Adhesive molecules with lengthy side chains have the best action. Best action is if it's fatty acid, you can see 6 or 14 carbon atoms in the cellular ester. So it's important of the branching of the adhesive molecule. It needs to stick the area. pH factor, effect of the pH. It's a strong acid, like a alkali in adhesive. It's not good effect, adverse effect of the bond strength. And protein glues, it's exhibit of the high adhesive activity in the presence of the lime, but it's get weaker pH So the organic plastics show better adhesive strength at the lower pH. I mean, it's acidic surrounded. What about the mechanism of the adhesion? For a good adhesive, it must be important of these factors. It must be able to wet all substrates, and it must harden, and it must be able to transmit load between of the two surfaces, adherent to adhesive. Unfortunately, there is no single theory of the covering adhesion, and particular mechanisms are specific to particle materials scenario. So we can take a 5 mechanic of the adhesion. It's mechanical, chemical, dispersive, electrostatic, and diffusion theory. We use both of them. In the mechanical adhesion, you can see adhesive and substrate. The adhesive materials fill all the voids and pour all the surface, and it will be hold together surface, and you can see interlocking. Look at that. It's a photograph from the scanning electron microscope, SEM. It's a composite regime. So it's indicate of the crack in certain area. It's bonding between of the adherent and glass immonorsement. It's a mechanical adhesion. And adhesion by the chemical sites, chemical bonding, of course. Chemical adhesion, it occurs when the surface atoms of the two separate surface by using of the bonds. Which bonds? Ionic and covalent, and also hydrogen bonds. If a surface molecules can bond, then the surface will be bonded together by the network of the balls. Dispersive adhesion, what does it mean? It's a good example for gecko adhesive systems. Can you see gecko? It's a macro, it's a meso, and micro, and we're interested in the nanostructure side. Two materials are held together by using of the van der Waals bonding. It's a dispersive of the adhesion. And London dispersion force are particularly useful for the functions of the adhesive devices because they don't require either surface to have any permanence of the polarity. Just van der Waals force is enough for dispersive adhesion. Of course, electrostatic adhesion, some conducting material, it may pass electrons to form the difference electronic charge at the joint contact area. This result in that structure is similar to copper and they create an attractive electrostatic force between of the material positive side and the negative side. It can be electrostatic adhesion. We use it. Some materials, they merge at the point of the diffusion. This may occur when the molecules of the both material, they are soluble in each other, and then the freedom of the movement, the polymers, they have strong effect on their ability. It's integrating and diffusing bonding. They are using generally of the chemical, not mechanical engineer diffusion adhesion. I want to show some link. Look at that A, B, and C. It's a cross-linked. Generally, when they are studying on the polymers, cross-linked polymers, they are less capable of the diffusion because they are bonded together at the many points of the contact. They are not free to the twisting, and adjust of the surface. What about of the linear polymer? Can you see is the linear polymer? In the other hand, they are free to wander into the adjacent path by extending of the tail, and they loop across in the interface. And is cis polymers, they are very free with the many tails extending across to interface area. We have another effect, the force, while the force themselves each contribute to magnitude of the adhesion between of the surface, they above play a crucial role. It's reliably on the adhesive device and overall strength is important. Look at that microstructure. Is technological advanced materials device sometimes make use of microstructure surface, such as periodic post and biomimetic. Biomimetic technologies is inspired by the adhesive abilities of the feet of the various vertebrates, like a gecko in their nature. Stringing. Stringing occurs when a separations between the two surfaces is beginning and molecule at the interface breach out across the gap, rather than it's like a crack. It's rather than crack like an interface itself. So if the failure is occurs at the interface containing of the viscoelastic adhesive agent, so we can say that crack does going a large line, crack does propagate. Wettability and absorption. The interfacial tension of the liquid and solid is directly related of the liquid wettability. Leaving in adhesive is exposed into the air too long gets its dry, of course, and its adhesive strength will decreases. The gas molecules take up potential size of the surface. So we can say absorption and we can say adsorption. Okay, absorption and adsorption is different. So wetting, all wetting surface is good for us. For this, look at that is angle is theta. If angle is theta is over than 19 degree, it's non-wetting surface. It's not adherent surface, it's not good quality, it's not good shear strength, not good peel strength. It's not enough for adhesive bonding joint. What about of the lateral tension? Lateral adhesion is the adhesion is associated with sliding one object on the substrate, such as slide a drop surface. It's naturally adhesive contact between of the flat surface and between of the liquid drop makes the lateral adhesion in that case. Look at that is the total lateral force is using of the surfacing of the Teflon EF as total lateral force and normal electrostatic force. So we take a considerations of the calculating of the adhesive strength. You take a considerations of the lateral adhesion effect. It's important for covering of the some metal like a Teflon. It's sometimes adhesion failure. It's because of the sunlight, because of the solvent, because of the physical stress. I want to show some adhesive failures by the video, cohesive and adhesive fracture. Yeah, I will show a video. It's a failure type. You can see it's a two plate. It's not beam, it's a two plate. Is loading in the external force according to the y-axis. When the loading is increases, and if you can see this type of the failure in adherent material, it means that joint is stronger than material is joining. And then in that type, if you can see failure between of the adhesive layers, you can say it's cohesive failure. Yes, it's simple. If you subjected load, same plate sample, at that time, it's a failure between of the adherent and adhesive surface and failure of the adhesive bond connections. Oh, it's a bad situations. We can describe main adhesive, adherent failure, cohesive failure, and adhesion failure. Adhesion failure is a poor bonding process. It's unacceptable for the mechanical engineer because we should calculating all possible situation. Yes. Cohesive, adhesive, and interfacial structure. What about of the mixed type? If the which it occurs with the crack propagates at the some spot in the cohesive and the others interfacial manner. You can use of the fracture jumping from the one interface to another. So it's alternating crack path type which occurs if the crack jump into the one to another surface. It's also not good for us for engineering. Because of the failure, it's sometimes surface contaminations, it's some failure problem. Sometimes we are not good of the wetting of the all surface. I mean that food wetting of the adherent, it's problem. And sometimes it's improper joint design and wrong by calculating all the stress concentrations on the adhesive layer, it causes the failure. It's major causes of the layer for adhesive bonding joint. For an engineer, look at this important thing. It's adhesive, it can be not compatible with the adherents. Adhesive, it's not compatible with the adherents. The failure of the adhesive, the wet of the adherent surface, and it's lead to adverse chemical reactions at the bond line interactions. When improper adherent preparations, it's lead to incompatible weighting of the adherents by the adhesive again, and void and spread. I mean inclusion materials like a gas, porosity forming at the bonding interface. And when we encounter of the weak boundary layers, weak boundary layers at the bonding surface, it's lead to improper design. What about of the internal? Internal stresses, it causes a major failure problem arising of the adhesive shrinking and arising of the differential between of the thermal coefficients factor. Expansions of the thermal coefficient factor, it had to be lower between of the adhesive and adhesion by using of the different thermal positions. Out of the plane of leverage loading of the arising from improper joint design, it's arising from the improper adherent surface and adhesive applications and improper curing or setting time. We have taken considerations of the all things. Yeah, you can design constellation. If the design joint is such a ways of the force load to be transferred to the joint in the favorable loading directions, it's just only pure tension, it's just only pure compression, and it's just only pure shear. You take a considerations of your loading condition. And orienting of the joint or designing of the joint element, and it's reinforced in a such way as to minimize unfavorable out of the plane loading. So we don't use of the peel stress. Orientation of the joint, you should take a consideration. And design joint to ensure of the uniformity of the thickness of the adhesive layer. Adhesive thin layer as thin as practical for maximize tensile and shear strength. Designing joints and their elements, it's a volatile components of the adhesive can be experiment or that absorbed of the adherents. Designing joint is competitions of the material will minimize of the stress arising from the different coefficients of the thermal expansion factor, especially if you use hard brittle adhesive, such as many of the inorganic types of the adhesive, inorganic of the cements of mortars. You can take a considerations of the coefficients of the thermal expansion. Joint elements and their assembly is facility adhesive applications in curing time at suitable curing temperature. Yeah, sorry.
Ya, beliau tadi sudah menyampaikan beberapa hal penting tentang konsep sambungan adhesif. Ya, mulai dari materialnya, metodenya, kemudian faktor-faktor yang mempengaruhi kekuatan adhesif serta aplikasinya. Nah, beliau nanti akan menceritakan tentang bagaimana memprediksi kekuatan adhesif, sambungan adhesif menggunakan finite element method. Beliau sedang mempersiapkannya sebentar lagi. Oke. Oke, jangan lupa nanti 10 menit beliau minta break waktu 10 menit untuk mempersiapkan demonstrasi tentang simulasi finite element untuk adhesive joint ya. Nah, selama waktu break ini eh, silahkan Anda siapkan pertanyaan terbaik Anda ya untuk beliau. Nanti Anda yang memiliki pertanyaan terbaik akan mendapatkan hadiah dari labnya Pak Alif, lab mekanika benda padat. Silakan. Oke, nah, nah. Apakah materinya menarik untuk Anda? Di mana menariknya? Nah, hmm. Ada yang penasaran enggak? Apakah sambungan adhesif itu sama kuatnya dengan sambungan keling atau las? Karena selama ini yang kita pernah kita lihat langsung sambungan adhesif itu untuk sol sepatu, ya kan? Bayangkan enggak kalau dipakai untuk pesawat aerospace structure? Hah? Takut enggak sih kalau Anda dibilang pesawat ini dibangun bukan dengan dikeling, bukan dilas, tapi dilem gitu? Hah? Kira-kira pengaruh enggak? Coba nanti tanyakan. Ya, tanyakan. Apakah kekuatan sambungan adhesif itu comparable, setara, sehingga bisa menggantikan jenis sambungan yang lain? Ataukah dia hanya supporting saja? Ya, benar-benar bisa menggantikan sambungan keling enggak? Bisa menggantikan sambungan las enggak? Ya, ya. Apalagi? Katanya memang menarik tadi. Ya? Hal apa yang kira-kira memantik rasa ingin tahu Anda? Kalau di buku elemen mesin satu itu adhesive joint ini sedikit sekali dibahas. Atau bisa dibilang Di beberapa buku tidak ada. All, all about stuff. Like uh, several years ago, we have some students who study the impact they have on the impact of several years ago. Yeah, both of them, both of them. Okay, Professor Mena will start the lecture again, and now she will show you the finite element model for adhesive joint. Okay, please take your time.
Basic joint. Okay. Yeah, for take a considerations of the aim of the good adhesive bond joint, in order to obtain maximum strength for a given area, bond of the structure efficiently, we take a considerations of the mechanical properties of the adherents, and we should take a considerations of the residual stress at the joints, It's located nearly adhesive end line, and we get through interfacial contact, and we take a considerations of the type of the loading, of course, is important, and it's necessary of the good joint design. Look at that. In the adhesive bonded joint is one of in which in under all practical loading conditions, and the adhesive is stress in direction is the best resistance of the failure for in the shear stress. You can see of the lap shear strength is the single lap. I will show. It's a single lap joint and double lap joint. One of them you can use of the similar or dissimilar material, and you can see it's similar and dissimilar material. It's a main type of the single lap joint and double lap joint, and it's a plain butt joint. Of course, it's not preferred because it's a poor resistance. And scrap is a scrap joint is very good for the subjected of the tensile load. And you can see of the another joint type. I want to show you of the landed lap. It's good landed lap. And what about of the strap? We can think of the line on this surface is adherence between of the them and between of the each materials like a plain bud. It is simple strap, and it's a look at a double strap. So you are a mechanical engineer. You have to comment of the design, and you choose of the good design by calculating of the mechanical engineering strength in the adhesive layer. It's important. Maybe one of you is interested in the master or PhD because it's a open study. It's not new, but it's open study. And I want to talking about the another excellent design geometry. We have an experimental of tongue on groove geometry. I have an experimental of that. It's a good joint design. What about of the chart? Look at that. It's important. Its axis, its x-axis is level adherence thickness, and the other y-axis is level as bonded joint strength. Look at all the joint type, please. You can see of the single lap joint, it's the lower bond joint strength because it's bending of the adherence due to the eccentric loading. So we have a residual stress at near this contact area. And what about of the double strap joint? In the double strap joint, it's more good than the single lap joint, but we have see peel failures. We have see in the peel failures. And then it's topper strap joints. Topper strap joints, maybe you can choose that design, but please attention to the shear failures. It's failures because of the shear stress. I mean that 2xy stress along to the especially this side and this near of the adhesive layer. And step lap joints or single step lap joint or tongue on groove joint. It's some shear failures also. And then you can choose a scruff joint like that one. And it's adherent failures at that time out of the joints, outside of the joints at the adherent. Sometimes it's failures. So good design. good design is important for us. I want to talk about a loading condition. You know, of course, you take a strength of the material lecture. Did you pass? Strength of the material lecture, yes. Of course, you can see tension and compression. If a geometry is strongly bonded with the together, and if you are loading of the tensile force, and F, what about of the shear stress? Shear stress is, of course, related to the force over related area. In that oblique plate, oblique area is related area, is oblique area. So I can accepting of the these cross sections is area. I can say these cross sections, of course, area multiplicate of the cosinus theta. Yes. And then what about of the its force? Its normal force, of course, is related of the F multiplied of the sinus theta. Yes. And you are calculating of the shear and normal stress at the oblique area. I can show you it's some base equations. If you are using of the moments, you can see it's a bending, it's a mechanical behavior, it's important mechanical behavior. It's a beam, not plate. It's just only beam, it's two-dimensional beam. If you are loading at the moment, so you can see the formations and you can calculating all the elastic curve for bending properties. And take a considerations. If you are adding of the moment in a scrap joint, it's basically take this shear stress and normal stress in there. Theta is a scrap angle. What about of the tubular scrap? It's a hollow part. It's like a pipe. It's important part of our area. When you are loading of the tension and compression, if radius inner and its radius outer, you can calculating of the shear and normal stress. I'm giving a lecture in the name is Advanced Mechanic in the Advanced Mechanic Theory in the adhesive bond joint in my university, and this is in the first lesson. And what about of the pure bending or pure torsion? You know that its torsion is generally using a solid cylindrical circle by adding of the moment according to this side. So this transitive torsion. And when you are loading of the torsions hollow part, you can see it's normal stress is equal to the 0 in the torsion because we have no stress according to the sigma xx direction. Its problem in the pure torsion is problem by shearing stress. Okay. What about of the maximum shear stress in adhesive occurs at the end of the lap joints? You can see in the single lap joint and subjected of the tensile load, its thickness of the P mean is as average. Its applied shear stress is equal to the F over BL, cross-sectional area, and L is over length of the adhesive. And you can use of these simple equations. In that equations, you can see of the big letter of the G. What is this? G. It's a shear modulus. It's related of the shear modulus, but it's related of the adhesive shear modulus. Okay. And I can say in that equations, of course, you know, it's elastic modulus, and length is, I mean that is overlap length. We take a considerations, and thickness one is adherent. It can be same or it can be different adherent of the thickness. I want to show you some graphic. It's a main graphic. Maximum to average shear stress. Average shear stress. I mean that. What is average? Is average is sigma maximum and over sigma mean. Is okay? Sigma maximum over sigma mean. It goes to the approach to the one. So P. P is subject of the load. P is becomes larger and larger. The degree of the stress concentrations is approach of the one. We take a considerations of the in that example, the adhesive gets stiffness. Adhesive gets stiffness relative to the adherent, and the modulus of the adherent gets lower relative of the adhesive. It's a mechanic of the adhesive, and it's the extent of the overlap increases, and either adherent or adhesive both get a thinner and thinner one. It may be a solution. You can see it's an anexentric loading. Can you see? Yes. You can use of the tensile load to do adherent. You can see it's a different axis. So the bending will occur. The bending is related of the basically P over 2 multiplied of the thickness. And if we assume that K is relative to the bending moment of the adherent end of the overlap, M is applied bending in plane loading, not out plane loading, in plane loading, and thickness of the adherent, we can define of the this. We don't want to take a considerations of these adhesive bonding joint. It's failure because of the bending moment. So attention that the two opposing force applied to the single lap joint, it's not a collinear axis. So there will be some bending. And the adherents are not completely rigidity. We generally accepting of the static, dynamic, and strength of the material lecture, all structure is rigid. But if the adherence not completely rigid, the band and allowing joint the rotate in the atom bring the long lines into the collinearity. Yeah, it can see. And very small loads, it's no rotation will cause. So higher applied loads, it lead to the severe out of the plane stress at the end of the overlaps for a single lap joint. These loads is joints because of the peel stress. Peel stress, I mean that's sigma xy. No, sigma yy is peeling stress. Yes. Can you see is a bond end? You can see of the shear stress. You can see of the shear stress is according to the A. And if you are adding all the some plate, you can see shear stress. It's this side, and you can see in that side. And it's like a, please see it's a single lap joint. Please see it's a double lap joint application. And you can see in the double lap joint, in the shear strength over to the bond lines. Yeah, this graphic is belong to the shear stress over to the bond line for the double lap joint. So considerations of the properties and use of the adhesive and environment. It's a failure load and the length. You can see length overlap with the constant and 1 centimeter. It's like this curve. And overlap like as a constant with the 1 centimeter. It's a failure load like linearly. It's from uh, from experimental results. It's not belong to me. The stiffness of the joint composed of the thin adherents, it can be increased by using of the double above and below primary adherents. So strong back stiffeners and the other technique can be used for good design. I want to show you a basic design because I'm not sure your level and I prepared a basic design. If you have an answers, we can do it together. If you cannot at that time, you can just only listen. We can definitions of the fixed point beam. It's made of the steel and is joined by orthotropic material whose properties are given. In tomorrow, I will lecture about the adherent material will be a functional gradient polymeric material. But this example is just only related of the linear material. It's steel. Yeah. You used the answers, I know. We will do a structure analysis. We can define a plane element. We take a considerations of its thickness. We had a real constant in the 10 according to this sample. You know, it's simple. We can define its simple beam. I'm sure you know the create a modular single or double lap joint, but I want to give some click point by take a considerations of the adhesive and adherent layer. We use of the some theoretical informations about penetration, about Gauss, some factors. I will show tomorrow. Yeah, it's loading. We can define of the yield stress. In that problem, orthotropic material, you know, orthotropic material has different mechanical properties according to the X, Y, and Z axis. What does it mean? It's elastic modulus, and then its position relation, and it has different shear modulus according to the 3 axes. We don't use temperature. We create a model. The model is a single lab. So you can easily draw a beam. So you know that we have some theoretical view according to the beam theories, according to the plane theories, according to the shell theories. In general, answers as options, it's like a glue. It's a simple options. You choose all the material and glue it, but it's necessary some detail. You choose all the material to get all the mesh. In some problem, in my students is a big problem by using all the answers. So in the answers, you can adding all the some numbers and you can get all the some numbers. But what about all the verifications of the answers? So if you are studying any topic, you verified it by using all the experimental or by using of the theoretical view. So if you are taking considerations of the meshing in the answers, you have to use of the mesh coverage systems. Of course, you know mesh coverage. So you first mesh all the structure and you try to solve, you get the data and you meshed again a finer mesh, again and again finer mesh. And when you draw a path, it's a coverage of the same line. So you should decide it of the okay, it's structure analysis, it will be acceptable. So mesh coverage is so important in my students, and I think in all the world students use of the answers not correctly way. Yeah, it's a fixed support. Fixed support, I mean that is restriction from the X, Y, and Z configurations. And you are loading of the tensile load. And you, yes, you are decided of the loading conditions. If the load not exactly directly all steps, so you should choose every step and you ask the answers, please write all outline data for the every step. The solution is done because the model is simple. You can see an iteration. I think, yes, I'm sure. We can take a considerations of the deformation, all particle, but in generally, we using of the look at of the adhesive layer. So you can see, you can draw a path according to the adhesive layer. Generally, you should choose a path in the midline layer in the adhesive and take a considerations of the in the midline is shear and peeling stress according to the bond line. So you draw a path, according to this side, and you should check of the shear stress. Because in the deformations is not interested the for mechanic. You can see in the all stresses, but in the all structure, all stresses, of course, is located at the supported line. You can use its real constant. Real constant was 10. It's chosen von Mises stress. And you can see animations of the von Mises stress by applying of the single lap joint. It's applying of the single force. It's basically. These analysis is not acceptable for the advanced mechanical engineer students because it's necessary to take considerations of the adhesive and adherent mechanic. So we take a considerations of the some factors, penalty stiffness factors, some Gauss factors we will discuss in the theoretical view in not today, maybe in tomorrow. My specific area is that, and it's the last of my presentation. I'm glad to be here. I'm happy to meet you. Okay, thank you for your attending and listening.
Do we have question answer now? Uh, yeah. Okay. Professor Mina already finished her lecture. Now is the question and answer session. If you have any question about the lecture, please raise your hand. Okay, 1, 2, 3. You first. Okay. In Indonesian or English?
No, not important.
Thank you very much. Okay, my name is Joan. I'm from master degree, and I want to ask, what is the surface treatment needs to be carried out when using adhesive in aircraft application to avoid adhesive joint failure? Because we know that the assembly application on aircraft must have very good connection strength because of the large force. Yeah, because in plane, in the aircraft, have the large force. Okay, and then for aircraft application, yeah, and in the second question is, can the application of adhesive on aircraft replace the function of other joint? For example, replace bolt joint in the aircraft. Thank you.
It's okay.
Thank you. Thank you for valuable questions. Firstly, first is these all educational analyzing and it's a theoretical analyzing. We take a considerations of the theory. So my area is mechanic theory, of course, but I don't talk about all the all structure analysis. Of course, all structure analysis is important, and you should check all the problem area, all the structure, maybe welded time, maybe adhesive part, maybe supporting type, but it's a theoretical view, I'm a theoretical study. We can take a considerations of the single lap joint. Of course, single lap joint, I mean that it's many parts. For example, my master degree is related of the plain body structure. It's body like that one, but we take a consideration just a part for theoretical viewing. Okay, of course, all structure take a consideration, and then maybe I'm not sure. Chemical surface proposition. I didn't interested in. It's related of the chemical engineering. Maybe I know just only attaching is generally used for surface progression. I generally interested in theoretical view. Thank you for your reliable question.
So next, please.
Firstly, thank you for this introduction about adhesive joint. I come from France and I have two questions. Firstly,
Please name.
yeah, my name is Raphael. Yeah. So firstly, what kind of tolerance can you affect when you use adherence project process? What kind of tolerance can you use? Yeah, tolerance. When you use some process like adhesive process, you know. And second question, earlier you speak about use adherence for steel, for between steel and steel. And why it's better to use adherence because you can also use welding, for example.
Why? Right? What does what is it going to get the other?
I'm sure.
Use welding trick, that's why you use adhesive chain.
Yeah.
Okay, maybe I will show. Yeah, from the video. Look at that. Yes, we take a considerations of the sun bonding method, welding or fastening. Of course, it's a method. It's a traditional method, but adhesive is not traditional method. It's prefer some area, especially is the lightless. Lightless is important for the maritime of the airlines or architecture lines. So generally, the use of the glue. For example, I'm giving an example is a pavilion. You know, a pavilion is an architecture structure full of the glass, full of the glass pavilion. Architecture takes considerations of the glue connections because they don't want to use fasten joints. They don't want to drill a hole in the glass. So it's a structure problem. they can use of the glass. And then sometimes is yes, sometimes is the advantage according to the fastening joint. For example, what does it mean a great fatigue resistance? You know it's a fatigue is loading conditions, uh, especially is the constructions. So in the fatigue is a problem at the two different materials because of the friction uh, problems, some problems of the belt and welded, of course. I'm not uh, professor in welding, but some problems. So it's a good corrosion resistance. So in the maritime, lightness and corrosion resistance, it's good. We don't prefer of the fasten because the metal to metal connection and under the water, it's problem. So we can choose the fasten. We don't choose the fasten. We can choose the adhesive is non-soluble in the water. It's a solution, I think. And stress concentration. It's a bigger problem is stress concentration because it's important part of the connection part and in the air or in the water, stress is better than adhesive convection. So we choose it. We choose it. Thank you for a reliable question.
And the next question is about the tolerance in preparing the surface before bonding. Is there any tolerance? The process? Oh, okay.
The
So,
second,
mhm.
second questions, I think, is related of the adhesive corrosion, but it depends of the study. We generally measurement of the corrosion in the surface. In really, we don't take a considerations of the super layer corrosion. It's not good for adhesive. Corrosion is necessary for interlocking, for chemical locking, of course, but not more reliable. So it's specific study. Depends.
Okay, thank you.
Okay. So then next, yeah, please.
Uh, my name is Yani. Uh, uh, what a what nega- negative effect in the physical factors? Example, in chemical factors. Effect, negative effect in chemical factor.
So if we use welding to join the part, we have heat affected zone as the negative effect from heating, right? So she asked, when we use adhesive bonding and and before doing the bonding, we apply the surface treatment using chemical etching, something like that. Do we have similar negative effect, just like heat affected zone? Is that your question?
Yeah.
Do we have any negative effect
Yes.
from surface
Yes.
treatment?
Yes.
Um, First, what was your name? What was your name?
Your name?
Yani.
Lenny.
Yani.
Yeah.
Yani.
Yanni.
Yani.
Yanni. Thank you for your questions. I want to talk about firstly academic generation, academic person in my country. We are women and 46 percentage of the academic in Turkey. Thank you for reliable questions because we need a girl power, and of course, and also our dean is woman. Our head of manufacturers division is a woman, so the woman is it will be good in their job, and it will be good for a good mechanical engineer. Thank you for your answer. And we can compare of the adhesive bonding or welding. We take a considerations of the just only one similar click point. Coefficient of the thermal expansion coefficient. We prefer always thermal expansion coefficients between of the adherent and adhesive. It should be lower. It's a click factor, but these applications always different from the velvet applications, is different metal to metal, and it's a big deformations. It's by using of the heat and it's changing of the all mechanical behaviors in this connecting area. Adhesive is different. We have any big deformable. We have any um, problem. We generally use and the normal standards, it's a room temperature by using of the application, and of course maybe etching and maybe contact of the surface is produced of the some temperature, but it's for us negligible. Okay, it's not important for us.
We can avoid. We can negligible.
Not important
It
for
is
us.
not significant.
No.
Okay.
Yes.
There any question? Okay, 1, 2.
Excuse me, my name is Chandra. I am from an undergraduate student. My question is it possible to use adhesive bond to join structural component made of carbon fiber reinforced polymer, example for assembly monocoque chassis? And what is the resistance to continuous vibration?
This is bonding going to dissimilar material made from non-metal polymer. How to reduce the effect of vibration?
Operation.
Yes.
Operation, but not operation.
Yeah. That's maybe want to know. Yeah. How? Yeah, the damping or if the structure vibrate, then there is cyclic loading. Yeah. So he asked about resistance. Can you repeat for the second question, please?
The second question is, what is the resistance to continuous vibration
The resistance
of adhesive bond?
of the bonding.
Yes.
I can answer like that. We take a considerations of the some loading conditions. So your questions is related of the damping load, okay, and in the fatigue. We define of the it's a elemental part according to the area, and we are loading in non-linear condition, loading condition. And then after non-linear loading condition, we first check is a crack effect is in there or non-crack in there. So if you use of the small crack in there, you can use some theoretical view, virtual crack razor method and another some methods. You should use of the them by the loading of the fatigue. So you should the mechanical properties of the adhesive you get into your analysis, and then you check the some gap. You firstly give a tolerate because you get some exactly real mechanical conditions like yield stress, another one. You have to know that, and adding all to this program and your restrictions of the strength, and then damping loading, you check the areas, but it has many different methods. So you can use advanced method. Some of them virtual crash technique like that. It's not just exactly answer. The resistance is that one is related to a simple thing, simple mechanical thing. It depends many variable thing.
So the first answer, of course, you can apply adhesive joint to join the dissimilar material. For example, polymer with polymer. You can use adhesive joint for that. And the second, to understand about the effect of vibration in this adhesive joint, you have to study the behavior. Because if you apply different material, then you will have different effect. Because when it has different young modulus, the vibration change. If you change the thickness of the adherent, the vibrations also change. If you are interested in the fatigue resistance, then you have to check the crack. When you make connection, when you make bonding, you have to check the crack, micro crack. If there is a single crack, then it will shorten the fatigue life of the joint. Is that right?
Yes, of course.
Is it enough? Okay, the last question. Practitioner, he developed the body of supercar
Wow.
or Formula SI or
Okay.
racing.
Yeah.
So that's why
My husband division has a exact material made with theoretical. When mathematical, I
Oh,
use
yeah.
MATLAB.
okay, different units,
Yeah,
practice and theory.
yeah, theoretical.
Silakan.
Okay, please.
Excuse me, my name is Jacob. So I want to asking about. I see in the presentation this adhesive joint as a two phase before it can be declared as a correct in its application. So first it is from a liquid, then it changes to be a solid. So the question is how to calculate and determine the strength of a adhesive joints when its use requires a material change space, which also definitely change the several types of material characteristics such as modulus of elasticity and the other things. So in the several type of joints in the application it depends on temperature. So there will be many variable that influence the calculation of the strength of the joint. So how to determine the strength of a joint adhesive if it has two pairs of the application? Thank you.
Okay, thank you, Jacob. Yes.
Um, in previous studies and experimental studies, we define of the mechanical engineer of the adhesive with adding of the nanoparticle parts. So it's a exactly one solution determine of the stress and strain curve. It's a tensile testing, you know. So we use adhesive and adding nanographen in the adhesive, and we have a new material. We have no idea about its mechanical condition. So we bulk it, we prepare it or tensile stress sample, and in the laboratory, we use a tensile machine and we draw stress and strain curve. You know that stress and strain curve and its incline, its behavior is gave us elastic modulus. So we can calculating by an experimental method by molding the tensile sample. And we used these experimental data in the numerical analysis.
Is it clear, Jacob?
There's one thing that I want to ask.
Mhm.
If we are talking about the nano molecule, it will be very dynamic characteristic. So how we can do the experiment about the right experiment of the nano structure if we do like that mismin do.
Could you explain more what is the relationship between nanostructure and adhesive joint?
That's the experiment that Miss Mina said before.
Yeah, yes, it's the experimental study. Our aim in that increasing of the mechanical behavior. So nanoparticle, not nanographen. Tomorrow I will discuss about nanographen adding of the material. It's behavior not like inclusion. Its behavior, it's tend to higher strength of the adhesive. We aim is higher strength, and we are adding of the nanographen or nanographite, both of them I did, and we try to get more strength, and it's importing modeling. It's importing modeling and it's importing theoretical view. When we discuss in the nanoparticle, we using of the some equations, how to say and Lewis model and how to say model. These are micromechanical model, but when you use macro level, and we can use some different theoretical view. We firstly using of the MATLAB by using of the theoretical view, and we using of the APDL in the ANSYS. So we are take its effect, its volume effect, its material effect. It's like that. Our aim is strength the bond line. Our aim is strength to adhesive characteristic, for example, elastic modulus and Young modulus. We want to get a more strength adhesive.
I want to add some more explanation. Is it okay? I want to add more explanation. Is it okay?
Yes,
Okay. Okay, so Mr. Jacob, if you want to predict the strength of the adhesive joint with different variation, we have three different methods to predict the strength or the mechanical behavior. First, we have analytical model. Is that right? Just like Professor Mina mentioned in this slide. We have several formula to know the stress distribution along the adhesive joint. We can use formula. But if you have complicated geometry of adhesive joint, this formula maybe cannot be used. We have to find another method. Second method, using finite element modeling, right? We can use numerical simulation to predict the strength, the mechanical behavior of the adhesive joint. And the third is doing the experiment. Okay, using those three methods, of course, eventually we will able to predict the mechanical behavior of the adhesive joint. You can change anything. In the simulation, you can change geometry, you can change the properties, and then evaluate what is the effect in the strength of adhesive in the bond condition. Okay.
Thank you, sir. I mean, if we are do simulation or do a numerical method, we especially in ANSYS we should giving properties like modulus elasticity and the Poisson ratio. So if do we use the adhesive joints, what are we?
You have to measure the properties. You have to know the properties of the adherent. You have to know the properties of the adhesive itself. That's why you have to do the experimental tensile test for bulk adhesive, tensile test for the adherent. Then you can, after you obtain the data, you can use it as input in the ANSYS. Is that right?
Yes. Just solution from base to experimental. Thank you. Thank you for your interest.
It's clear, sir.
Question then. Thank you for your attention and the contribution in this guest lecture. See you tomorrow morning. Okay? Ah,
Class.
Professor Mina want to have a picture with you. Is it okay? Okay. Ah,
Mungkin teman-teman bisa berdiri. Three, two, one. Okay. Three, two, one. Thank you.
and please do not forget for the student who give the question, please give us your phone number because there is a voucher for you.
Yeah, great.
Yeah, we have copay voucher for you for each question. Okay. Just send me your number. Give me your number. Yeah, yeah. Please list the number and send to me. Okay. Thank you so
very
much.
much. Thanks.
See you again tomorrow morning.
And also, if you're
No, different.
different.
Tomorrow morning will be Mr. Saifuddin.
Okay.
He is the supervisor of those exchange students.
Okay.
And his expertise is in biomedical engineering.
Biomedical.
Yeah.
I will lecture is related to the functional grade of polymeric material and its analyzing.
Yes.
Maybe it's the material type.
That will be good.
Because it's not
Sure.
not possible overlap all lectures.
Yes.
It's okay? It's okay. I mean, and can